There are questions that arrive in the mind like a whisper, drifting in so softly you hardly notice them at first. And then there are questions that stand in the middle of the night sky, vast and immovable, reshaping everything around them simply by existing. Black holes are one of these questions. They do not invite easy answers. They are the deep wells into which the universe has poured its extremes: gravity without end, space without escape, time without guarantee. And yet, the more we look toward them, the more they seem to be looking back, or perhaps looking through us, indifferent to the fact that we are asking anything at all. This is where our journey begins, with a question so strange it could only belong to both science and philosophy. Are black holes keeping secrets from themselves? When you first hear it, the question sounds impossible. How could anything hide something from itself? It's like asking whether your own mind could hold a thought it never quite knows it's thinking. And yet, when we turn our gaze toward these dark anchors of the cosmos, the idea begins to take on shape. A black hole, after all, is a place where space folds inward so completely that even light cannot return. A place with no clear inside and outside in the way we understand those words. A place where the rules of reality, the dependable equations that keep planets in their orbits and keep your feet on the floor, break in a quiet, unobservable collapse. It is not only that black holes keep secrets from us. It is that deep within their own structure, there might be regions forever closed off, even from their own unfolding history. We live in a universe that, for the most part, lets its truths be known if you look closely enough. We can measure the spin of distant galaxies. We can decode the faint afterglow of the Big Bang. We can even watch the flicker of atoms exchanging their quiet energy. The universe, for all its immensity, offers signs, patterns, whispers that we can piece together. But black holes are different. They draw in the signals before they reach us. They erase the clues before they can be read. They end the conversation before it begins. The event horizon, the boundary around a black hole, is not a wall in any physical sense. It is simply the place where paths of light and matter curve so sharply inward that there is no return. Anything crossing it is no longer part of our shared universe in the way we can measure or know. If we imagine the cosmos as a great library of everything that has ever happened, a black hole is like a sealed vault deep within it, one that does not just refuse entry, but refuses even to confirm whether the vault has a key. And so, for decades, physicists, philosophers, and dreamers have stood at the edge of this invisible threshold in their minds, wondering not just what is inside, but whether the inside can ever be aware of itself. Because here is the strange thing. Even the matter and energy falling into a black hole are not falling into a simple, fixed container. They are falling into something that is itself changing because of what falls in. The black hole is shaped by its own history, and yet it might not be able to access all of that history from within. It is a bit like writing a book, one page at a time, and then sealing each completed page in an envelope you can never open again. The story is there. It shapes the meaning of what comes next. But the earlier parts are gone to you. You can only imagine them from the way the later pages unfold. When we speak of black holes, we often slip into language of fear, devourers of stars, cosmic traps, points of no return. But tonight, we will speak of them differently. Not as monsters, but as puzzles. Not as destroyers, but as keepers of something too deep for ordinary space and time. Our journey will be slow. We will walk the edge of these gravitational abysses, sometimes peering inward, sometimes turning outward to see how their presence changes the space around them. We will listen to the theories, some precise, some wildly speculative, about what becomes of the matter and information that cross the event horizon. And always, we will circle back to the question, could the black hole itself be missing part of its own truth? Could the extreme bending of time and space create a kind of self-forgetting in which the whole cannot quite see all of its parts? In asking such questions, we do something very human. We reflect ourselves into the universe. We see in black holes a shadow of our own mysteries, the unspoken memories we carry, the thoughts we cannot reach, the dreams we have forgotten yet still shape who we are. Because perhaps this is not just a question about physics. Perhaps it is also a question about consciousness, about whether anything, a mind, a planet, a galaxy, a black hole, can ever fully know itself. The night sky is full of points of light. We can map them, name them, trace their motions through centuries. But there are also the places where light has been taken away, where no star shines, where the blackness is more than absence. It is presence. These are not empty spaces. They are filled with the weight of what has gone in and will never come out again. They are places where the universe writes its most private chapters. As we begin, let us stand at this edge together. Not in a hurry to cross, not in a hurry to solve. Just letting the enormity of the question settle into us. Bending the night in a way that makes it feel longer, deeper, more still. We will wander from the birth of black holes and the deaths of stars to the subtle ripples they send through space-time. We will trace the slow unspooling of their mass through Hawking radiation and the even slower unspooling of our understanding as we try to match equations to something we cannot see. We will listen to the arguments between physicists who believe information is lost forever and those who believe it must be preserved in ways we do not yet understand. And we will let those arguments become more than science. They will become meditations on what it means for anything to hold a secret. Some secrets are kept for safety. Some are kept because they cannot be spoken. And some are kept because even the keeper cannot find them again. As our journey unfolds, this will be the question we will keep close. When the universe hides something, is it always hiding it from us, or might it be hiding it from itself? The night stretches on. The stars keep their distance. Somewhere in the depths beyond those stars, black holes continue their silent work, swallowing, shaping, sealing. They are not hurrying. They have nothing to prove. And yet, they may be holding something even they will never know. We begin here, with the stillness before the descent. Gravity is often imagined as a force that pulls, as if invisible strings tie every object to every other. But in truth, gravity is not so much a pulling as it is a shaping, a quiet bending of the stage on which all motion takes place. It does not roar. It does not rush. It waits. It molds. It sculpts the paths that stars will follow for billions of years. Black holes are born from gravity's most patient work, not from a sudden impulsive act, but from the long inevitability of a massive star exhausting its fuel. For most of its life, a star is in perfect balance, gravity pulling inward, pressure from nuclear fusion pushing outward. Hydrogen becomes helium, helium becomes heavier elements, and each reaction sends light and heat flowing into space. The star shines because gravity and fusion agree to hold each other in check. But this agreement is temporary. When a star far more massive than our Sun reaches the end of its fuel, fusion falters. The outward pressure that has kept gravity at bay weakens. And gravity, patient for millions of years, finally moves without opposition. It does not move in haste. It moves with precision, folding the star inward, layer upon layer, until the core itself is crushed beyond anything familiar. At this scale, there is no stopping point. Once the collapse begins in a star massive enough, no known force can resist it. Matter is pressed to densities beyond comprehension. Atoms themselves, those sturdy building blocks of all we know, are forced to surrender their structure. Electrons and protons merge into neutrons, and even these may not survive the descent. The collapse becomes total. The star's core shrinks past the size of any ordinary object, past the density of any solid, past the very possibility of standing still. In that moment, a black hole is born. From the outside, The birth can be dramatic. The star's outer layers exploding outward in a supernova, scattering elements across space, seeding the galaxy with the carbon, oxygen, and iron that will one day make planets and people. But at the center of that cosmic flower, a different story is unfolding. The creation of a gravitational well so deep that nothing, not even light, will climb out again. It is here that the event horizon takes shape, not as a solid surface, but as a boundary in spacetime itself. Cross it, and the universe beyond becomes unreachable. Stay outside it, and what lies within is forever out of reach. We might think of the black hole as an object, but it is more like a place, a region of space where gravity has shaped the rules differently. Inside, all paths point inward. Inside, down is not toward a center in the usual sense, but toward a future that all matter and light must share. And gravity does not simply stop shaping here. It continues its work, tightening space and time into configurations no eye will ever see. In its silent architecture, it may hide layers and curves that remain unvisited even by the matter that falls inward. This is what makes black holes so strange to think about. They are not built of matter in the way that planets or stars are. They are built of geometry. They are the ultimate design of gravity, a structure without walls, a cathedral made entirely of bent spacetime. And yet, for all their elegance, they are also incomplete in a way that troubles our understanding. Our equations break when we try to describe their very heart, the singularity. We can trace their outer forms, but not the inner shapes gravity may create beyond the horizon. Could those inner shapes hide from each other? Could different layers of a black hole's architecture remain forever unconnected, never exchanging the histories they hold? It is here the central question starts to echo, not just in metaphor, but in the strange mathematics of relativity and quantum theory. From great distances, a black hole might seem static, unchanging, just a dark sphere against the starfield. But gravity's design is never still. Every particle that falls and changes the whole, every photon that grazes the horizon leaves a trace in its curvature. The architecture is alive in the slowest, most enduring sense. We stand at the threshold of this invisible construction, knowing only that it began with the fall of a massive star, and that, once begun, it cannot be undone. The rest is hidden from us, perhaps hidden even from itself. In the silence between thoughts, you might imagine it, an unseen cathedral of gravity's making, arches of space-time curving inward forever, a space built not to be entered, but to hold the mystery intact. There is no signpost, no shimmer in the air, no line that glows in warning. The event horizon is not a wall. It is a boundary written into the fabric of space-time itself, a place where the paths of light and matter curve inward so completely that there is no way back. Once crossed, the concept of returning loses all meaning. If you were to approach it, nothing would announce the moment of crossing. No sudden darkness would fall. The stars would still be there behind you, though stretched and warped in strange distortions. You could pass this invisible threshold without realizing it had already claimed you. And yet, from far away, the story is different. To a distant observer, you would appear to slow your motions, stretching towards stillness as you neared the horizon. Light from you would redshift, fading into deeper and deeper tones until you were no longer visible at all. From their perspective, you would never quite cross. You would simply fade into the edge forever. This is the strange duality of the horizon. From the outside, nothing escapes. From the inside, there is nowhere to go but deeper. It is a one-way crossing, not because of a barrier, but because the very shape of space-time tips inward. It is as if the horizon is the rim of a great waterfall, but one where space and time themselves are the water. Once you are over the rim, every path forward takes you down. The horizon does not destroy. It does not crush. It simply severs connection. What happens beyond it is sealed off from the rest of the universe's unfolding story. Here, our central question starts to breathe again. If what lies beyond the horizon is disconnected from the outside, might it also be disconnected from parts of itself? Could the black hole's interior have regions unreachable even by the things already inside? We are used to thinking of space as continuous, a kind of open map where every point can be reached from any other if you travel far enough. But near the horizon, the map folds in ways we cannot follow. Distances and directions lose their ordinary meaning. To imagine this, think of a dream you cannot escape, where you walk through corridors that loop back on themselves, where the door you just passed through leads somewhere you do not expect. Inside a black hole, this looping is not a trick of the mind. It is the very geometry of reality. From the outside, the horizon is finality. Once something crosses, its details are lost to us. We can measure its mass, its spin, its electric charge, but nothing more. All other qualities, the arrangement of atoms, the story of how it came to be, are erased from our reach. Some physicists believe these details are gone in an absolute sense, destroyed at the horizon itself. Others believe they are still there, in some encoded form, written into the horizon's surface or preserved in ways we do not yet understand. This disagreement is not just academic. It touches the very foundations of physics. If information can truly be lost, then the laws of quantum mechanics, which insist that the universe's past can always be, in principle, reconstructed, may not be complete. The horizon becomes a test of whether reality is fully knowable, even in theory. For those who fall in, the horizon is less dramatic. No physical sensation marks the crossing, unless the black hole is small, in which case the tidal forces would tear you apart before you even got close. But for the truly massive black holes at the hearts of galaxies, the crossing would be eerily calm. You would drift past an unseen boundary, unaware that your path forward had been narrowed to one possible future. In that sense, the horizon is not just a line in space. It is a line in time, a place where your remaining future is limited, and every second moves you closer to the singularity. The more we think about the horizon, the more it resembles other boundaries we encounter. Moments in our lives we cannot undo, choices we cannot unmake, days that split our personal histories into before and after. In the black hole, such a division is perfect and permanent. It is tempting to think of the horizon as a keeper of secrets, holding back what lies beyond. But perhaps it is more accurate to say that the horizon is the secret itself, the shape of the divide, the unseen moment where connection is cut forever. Around it, the rest of the universe goes on. Stars burn and die. Galaxies spin in their silent grace. But within the horizon, the story turns inward. It folds into layers we cannot peel apart, into a geometry we can only guess at. As we stand here in thought, at the very lip of this ultimate divide, we can look outward and see the familiar universe, or inward into a darkness that has never sent back a message. To take the next step is to abandon every tether to the outside. And for a black hole, that step is inevitable. Matter falls. Light bends. Time itself is drawn in. The horizon does not move toward you. You move toward it. And once you cross, All that remains to the outside is the faint imprint of your existence, a fading mark on the curve of space-time. In the next part of our journey, we will let go of the edge and imagine what it means to drift inward, toward the singularity itself, that hidden center where the laws of physics are said to unravel completely. It is there, if anywhere, that a black hole's greatest secret is kept. Beyond the horizon, there is no turning back. The path is not a choice. It is the shape of time itself, curving toward an inevitable end. The singularity waits there, not as an object in the ordinary sense, but as an ending written into the equations of general relativity. It is the place where space-time folds so tightly in on itself that the curvature becomes infinite, where density and gravity grow without bound, and the familiar scaffolding of reality, the rules we rely on, collapses under their own weight. From our perspective outside, the singularity is an idea. No light reaches us from it. No message can escape. It exists as the limit point in the mathematics, the destination toward which all falling matter is carried. From the perspective of something inside, the singularity is not a distant point in space. It is a point in time, the final moment toward which every path leads. Infalling matter cannot orbit around it indefinitely. All roads run straight into it, not in distance, but in duration. It is, in the starkest sense, the end of your future. This is the quiet cruelty of the singularity. It is inescapable but invisible until the very last instant. You cannot turn away because turning away is no longer possible within the shape of space-time you inhabit. The geometry allows only one direction, inward. And yet, here is where our central question takes on its most unsettling form. The singularity may not simply be hiding from us. It may also be hidden from itself. Inside the black hole, time and space are so deeply altered that different regions may be forever sealed off from each other. Matter falling in at one moment may never be able to communicate, even in principle, with matter that fell in at another. The black hole's own history may be scattered within its interior, unshared, unreconciled. Imagine a library where the shelves have collapsed inward, trapping each book in its own sealed compartment. The knowledge is still there, but each volume is alone, unable to touch the others. The black hole might be such a library, a keeper of records that can never be gathered into a complete story, even from within. This is one of the strange consequences of Einstein's equations. When pushed to their extremes, the black holes inside may not be a single, unified space, but a fractured geometry of unconnected regions, each ending at its own singularity. If that is true, then the black hole self is not a whole thing at all, but a collection of endings, each cut off from the rest. Physicists are divided on what truly lies at the singularity. General relativity says it is a point of infinite curvature, a place where our equations stop making sense. Quantum mechanics whispers that infinities are signs that our theory is incomplete, that something else must take over at the deepest scales. Some dream that inside a black hole, matter does not collapse to a single point, but is somehow transformed, perhaps stretched into another dimension or reborn in a new universe, budding from the old. In this view, the singularity is not a dead end, but a seed, a point of departure rather than finality. Others argue that the singularity is not a thing at all, but simply the place where our current understanding breaks, where our mental maps end in blank space labeled, "Here be dragons." The truth is we cannot yet know. Every path to observing the singularity is closed. Every clue is locked inside the horizon. We can only infer its nature from the mathematics, from the way a black hole shapes the world around it. And so we return to our metaphor, the whisper. The singularity does not speak in words or signals. It speaks only in the language of gravity, in the slow pull it exerts on the stars, in the faint ripple of space-time when two black holes merge. From these traces, we guess at the shape of the unseen. But even in these whispers, there is uncertainty. Are we hearing the voice of the singularity itself, or only the echo of the space around it? Is the heart of the black hole truly present in these signs, or has it already slipped beyond the reach of any telling, even its own? Standing here in thought, deep inside this imagined journey, we are surrounded by silence. Not the silence of emptiness, but the silence of something holding its words, keeping them close, refusing to spill them even to itself. This is where the black hole feels most like a mirror to our own inner depths. We too have places we cannot reach, memories forgotten, thoughts that never fully take shape, corners of our minds where the light has never gone. And perhaps, like the singularity, those places are not empty. Perhaps they are simply beyond the part of ourselves that is able to look. In the next part of our journey, we will rise slightly back from the heart of the black hole to consider one of the most perplexing debates in modern physics, the information paradox. It is here that the tension between relativity and quantum mechanics comes into sharpest focus, and the question of what a black hole knows, or doesn't, takes on a new urgency. For most of physics, there is a quiet faith in the permanence of information. Not permanence in the sense of photographs or written records, those can fade and crumble, but permanence in the deeper mathematical sense. In this view, the universe is like a perfect ledger. Every event, every interaction, every subtle exchange between particles leaves a mark, and that mark is never erased. It may be scattered and transformed beyond recognition, but somewhere, written into the fine details of the universe's quantum state, it remains. This is the law of reversibility, the idea that, in principle, if you knew the exact state of the universe now, you could work backward to reconstruct everything that has ever happened. Black holes threaten this law. When matter falls into a black hole, all the rich detail that once defined it, the arrangement of atoms, the shapes of molecules, the way it was moving, is stripped away from the outside view. The only properties that remain visible are a few simple numbers: the black hole's mass, its spin, and its electric charge. It is as if the entire life story of the matter has been condensed into a single, nameless entry, added weight. If the black hole then evaporates through Hawking radiation, and that radiation is purely random, carrying no imprint of what fell in, then the ledger is broken. The story is not just hidden, it is gone. This is the essence of the information paradox, first made famous by Stephen Hawking in the 1970s. According to Hawking's early calculations, the radiation emitted by a black hole has no memory of what the black hole once contained. It is thermal, featureless, without pattern. When the black hole eventually disappears, the information about what fell and has not been released into the universe, it has been destroyed. The problem is that quantum mechanics insists this cannot happen. The laws governing particles at the smallest scales require that the past be recoverable, at least in principle. To lose information completely would be to shatter one of the most fundamental rules we have. Physicists have wrestled with this conflict for decades. If Hawking's original conclusion was right, something deep in our understanding would have to give. Either quantum mechanics, our most precise theory of nature, would need rewriting, or black holes are not quite what we think they are. Some have argued that the information must be preserved at the event horizon, somehow encoded in its surface area, like a cosmic hologram. In this view, nothing is truly lost. It is simply stored in a form so subtle and alien to us that it appears gone. Others propose that the information is released back into the universe, but only very slowly, encoded in delicate patterns within the Hawking radiation itself. Like smoke from a fire, the radiation might carry faint traces of what once burned within, if only we knew how to read them. And then there is a more unsettling possibility, that both sides of the paradox are somehow true. That information is destroyed and preserved, depending on who, or what, is doing the observing. From outside, the story might be gone. From inside, it might still exist, sealed beyond reach. This is where the paradox begins to echo our central question. Could the black hole be holding truths that it cannot, in any meaningful way, share with itself? Could the different versions of reality on either side of the horizon mean that the black hole is, in effect, split in its own knowledge? Hawking himself eventually revised his position. In the early 2000s, he conceded that information might not be lost after all, that the event horizon could, in some way, allow it to leak back out. But the details of how remain unresolved. Even now, the debate continues. Theories are tested against the mathematics of relativity and quantum mechanics, sometimes agreeing, often clashing. Each new proposal, firewalls, holographic principles, entangled horizons, feels like another shape passing behind an opaque curtain. We see the outline, but not the thing itself. For the listener drifting in the space between science and dream, the information paradox can be felt as more than an abstract dispute. It is the meeting point of two deeply human instincts: the belief that no part of reality is ever truly gone, and the fear that some things may vanish beyond all recovery. It is the tension between the archivist and the abyss. If the archivist is right, then somewhere, somehow, every photon's path and every atom's dance still exist, even inside the black hole's darkness. If the abyss is right, then black holes are not just keepers of secrets. They are erasers, unmaking the very fabric of the past. Perhaps both instincts are correct in different ways. Perhaps information, like memory, can be both present and inaccessible, both real and unreachable. A black hole might be a vault whose contents have not been burned, but sealed so completely that even the vault itself cannot open its own door. And if that is true, then the information paradox is not simply about whether the universe's laws hold. It is also about the nature of knowing, about whether it is possible for something to contain knowledge that is forever beyond its own reach. In the next stage of our journey, we will explore the quiet fate of black holes over unimaginable spans of time, the slow fading of giants through Hawking radiation. And we will ask whether this long decay is a kind of confession, or whether, in dissolving, the black hole lets its secrets slip away forever. For most of their imagined existence, black holes seemed eternal. They were the cosmic strongholds from which nothing could escape, not even light. The ultimate destinations of matter and energy, silent and immutable. But in the mid-1970s, Stephen Hawking showed us something astonishing. Black holes, he realized, are not entirely black. At the edge of the event horizon, the strange quantum world reveals itself in ways Einstein's classical gravity never predicted. Empty space is not truly empty. It seethes with brief, flickering pairs of particles popping into existence, only to annihilate one another in an instant. One of these pairs may form just at the edge of the black hole's horizon. If one particle falls in and the other escapes, the escaping particle becomes real, carrying energy away from the black hole. This is Hawking radiation, a faint, ghostly glow from the very boundary of darkness. The consequence is profound. Every escaping particle steals the tiniest fraction of the black hole's mass. Over time, the black hole shrinks. Its horizon pulls inward. Its gravity weakens. This is evaporation, but on a timescale almost beyond comprehension. For a black hole of a few solar masses, the process takes vastly longer than the current age of the universe. The great stellar remnants we know today will persist, quiet and patient, for 100 billion times longer than all of cosmic history so far. And yet, Hawking radiation means that they are not forever. They are not monuments in stone. They are candles with flames so small that the wick burns for eons, but still burns. In the early stages, the radiation is unimaginably faint. For a black hole the mass of our Sun, the temperature of this radiation is only a tiny fraction above absolute zero. The glow is invisible to any practical instrument, drowned out by the faintest whisper of cosmic background light. But as the black hole loses mass, the process accelerates. Smaller black holes radiate more intensely. As their mass drops, their temperature climbs. What begins as an imperceptible trickle becomes a stronger stream, then a torrent of high-energy particles. In their final moments, the black holes blaze. The last heartbeat of their existence may be a violent, brief release, a burst of radiation that carries away the last memory of their mass. For the poetic mind, there is something haunting here. A black hole spends most of its life as a keeper of secrets, an island of silence in the flow of the universe. But at the very end, it speaks. The Hawking radiation is a whisper at first, then a murmur, then a final desperate shout. Though whether that shout contains truth or only noise remains an open question. It is as if a giant, after sleeping through countless ages, wakes only to dissolve into light. The scale of this fading challenges our intuition. Imagine watching a mountain erode, not over centuries or millennia, but over spans so long that stars themselves are born and die in the meantime. Imagine an ancient fortress whose walls wear away grain by grain, while empires rise and fall unnoticed in its shadow. That is the kind of patience the universe demands when waiting for a black hole to vanish. And yet, this slow fading is not uniform across all black holes. Small hypothetical black holes, sometimes called primordial black holes, could have formed in the chaos of the early universe, only a fraction of a second after the Big Bang. Some may have been tiny enough that their evaporation time was short on cosmic scales. These would have burned brightly in their final moments, perhaps even long before galaxies had fully taken shape. If such black holes existed, some may still be vanishing now, their deaths marked by sudden bursts of gamma rays. We search the sky for such flashes, for these potential signatures of the universe's earliest and smallest giants meeting their end. But for the great black holes we know, the stellar mass ones left behind by supernovae and the supermassive ones anchoring galaxies, the fade will be so gradual that no present-day observer could hope to notice it. They will remain for untold trillions of years, long after all stars have gone out, after even the galaxies have dispersed into the dark. The universe's last chapter will be written in their slow, patient decline. If Hawking radiation truly carries information about what has fallen in, then this fading might be a kind of cosmic confession, a gradual unspooling of the black hole's memory into the void. But if the radiation is featureless, then the end is a final, absolute erasure. The paradox we explored in the last section still lingers. Here is the black hole's last act, one of release or of silence. We do not yet know. The mathematics tells us the energy must come out, but whether the story comes with it is still in dispute. There is also a deeper philosophical echo to Hawking's revelation. It reminds us that even the most seemingly permanent structures are subject to time. That nothing, not even the great engines of gravity, escapes the slow workings of the universe's change. It is a humbling thought, and perhaps a comforting one too, for it means that the cosmos itself is not a frozen stage, but a living story in which even the mightiest characters have their entrances and their exits. The fading of black holes marks one of the farthest horizons of time we can imagine. Beyond it lies a future where no stars shine, no warmth remains, and only the faintest embers of matter persist. This is the long dusk toward which the universe drifts, a time when even darkness itself evaporates. In the next section, we will follow that drift further still into the deep future. We will imagine the last ages of the cosmos when the black holes are gone and ask whether anything remains to bear witness when the final light fades. There will come a time when the last star burns out. Its light will cross the widening gulf of space and fade into the chill. No new suns will ignite to replace it. The furnaces that powered the cosmos for billions of years will be gone. What remains will be a universe without dawns, only the endless stretch of night. By then, galaxies will have thinned into ghostly shadows of their former selves. Their stars will be gone, their shapes barely distinguishable in the darkness. Matter will drift apart under the slow push of cosmic expansion. The Milky Way, Andromeda, and all their companions will long since have merged into a single bloated remnant galaxy, and even that remnant will have dispersed its last light. The universe will not be empty, not yet. It will be littered with the relics of brighter ages. Cold, dead stars, white dwarfs that have cooled to blackness, neutron stars frozen and silent, planets wandering with no suns to circle, and the great black holes still lingering, like titans in exile, slowly evaporating through the faint whisper of Hawking radiation. But the warmth of starlight will be gone. The only light will come from the slow decay of matter itself, the faintest glow from the breakdown of particles, if such decay occurs at all. The temperature of the cosmos will fall toward the absolute zero of thermodynamics. Not instantly, but so slowly that time itself will seem meaningless. There will be no cycles, no seasons, no markers of change. Just an endless unfolding into deeper stillness. Entropy, the great equalizer, will continue its patient work, scattering energy until no place in the universe is warmer than any other. This is the heat death, not a death in fire, but a death in perfect sameness. For us, who are creatures of contrast, who live in the difference between light and shadow, warmth and cold, it is difficult to imagine such a place. We depend on gradients, heat flowing to cold, energy flowing to where it can do work. In the long night, there will be no gradients left. The universe will be a vast, uniform sea of energy, unable to flow, unable to change. The timescales defy comprehension. 1 trillion years will be only the first breath of this night. Quadrillions will pass, and still the darkness will deepen. Time itself may lose its meaning when nothing in the universe changes enough to mark its passage. If there are any survivors from earlier ages, machines built by civilizations that learned to stretch their lives across eons, they will face an impossible challenge. They will need to extract work from a cosmos that has no temperature difference, no free energy to harvest. Perhaps they will go into hibernation for unimaginable spans, waking only briefly, like sleepers surfacing for a moment before sinking back into dreams. Perhaps they will migrate toward evaporating black holes, drawing power from the last embers of Hawking radiation. But even those embers will die out. Eventually, the black holes will vanish, one by one, leaving only the cold mist of particles they release in their final moments. When the last one fades, there will be no more bright flares in the dark, no more centers of gravity around which to orbit. Matter itself may decay, protons unraveling into radiation. If it does, the final transformation will scatter the last structured particles into diffuse energy, until nothing remains but the thinnest possible haze of photons and leptons, stretched by expansion to wavelengths so vast they cannot interact with anything at all. If protons do not decay, then the long night will be populated by inert, eternal matter, an endless cemetery of cold relics drifting in infinite darkness. In this age, space will be vast beyond reckoning. Expansion will have carried every remnant of matter so far apart that no two particles will ever meet. Distances will become meaningless when there is nothing left to cross them. And the silence will be complete. No light, no motion, no heat, no change. Here, the philosophical mind hesitates. For we wonder, if nothing changes, does time still exist? Or does time, too, fade with the last flicker of motion? Some physicists suggest that, in the ultimate heat death, time loses its arrow. Without differences in energy, without events to measure, time becomes an abstraction with no anchor in reality. In such a universe, there is no before or after. There is only is. We might imagine this as the death of the cosmos, or perhaps, more strangely, as a kind of cosmic sleep, a sleep from which it will never wake. This thought invites another. If awareness could somehow survive in such an environment, what would it perceive? Without contrast, without change, without light or dark, awareness might dissolve into the same undifferentiated stillness as everything else. The mind might lose its shape, as if thought itself were subject to entropy. But the long night is not necessarily the end of all possibility. In the mathematics of quantum mechanics, the vacuum is never entirely featureless. Even in the deepest silence, there may be fluctuations, tiny spontaneous shifts in the quantum field. Over incomprehensible timescales, these fluctuations could give rise to something unexpected, a new particle, a new spark of energy, or even, as some speculative models suggest, a new Big Bang. In that way, the death of one universe could be the seed of another. Perhaps the long night is not the final page, but the moment when the book closes before another begins. Yet, for our purposes here, in the warmth of a still young cosmos, the long night is a distant vision, a future so far away that it cannot truly touch us. And still, it exerts a strange pull on the imagination. There is something serene in the idea of an entire universe coming to rest. Something almost sacred in the thought of all the chaos, heat, and motion dissolving into stillness. It is the final exhalation of the cosmic breath. In the next section, we will turn from this quiet to the question of what it means for the universe to have a finite story. We will explore the philosophical and emotional implications of living in a cosmos that began, will end, and exists in a narrow slice of time between nothing and nothing. Because if the long night awaits all things, it asks us, what does it mean to shine briefly in the middle of such an endless dark? Let me know if you need any further adjustments. It is a strange and humbling thought. The universe had a beginning, and one day it will have an end. Everything we have ever known, from the earliest stars to the thoughts in your mind right now, exists in the slender space between these two eternities. The cosmos is not infinite in its story, even if it is boundless in its size. For most of human history, we imagine the universe as eternal, the stars above unchanging, the heavens fixed. The idea that there could be a first moment of time and someday a last is a relatively new wound to our certainty. It reframes existence. If there is a beginning, then the universe is not just a stage where events happen. It is itself an event, an occurrence. And if there is an ending, then our entire cosmic epoch is nothing more than a passing scene in a play that will eventually fall into silence. This finitude changes the way we think about meaning. If the universe were eternal, perhaps meaning could rest in the comfort of permanence, in knowing that the stars we see tonight would shine forever. But in a finite cosmos, meaning becomes something else entirely. It becomes about being here now. A finite life, whether the life of a star, a planet, or a conscious being, gains its poignancy from the fact that it is not endless. The cherry blossom is beautiful, not despite its fragility, but because of it. We stand beneath its petals and feel the sharp sweetness of knowing they will fall. The same is true of our cosmic moment. We are living in an age of light, one of the very few times in the universe's history when galaxies blaze, stars are born, and worlds can cradle life. There is a deep privilege in existing now. We inhabit what cosmologists sometimes call the stelliferous era, the time when stars still burn and planets still orbit them. This age will last for trillions of years, but compared to the eternity of darkness that will follow, it is brief. In the long night that comes after, there will be no observers to witness the beauty of galaxies. No eyes to see the dust lanes of the Milky Way or the sunrise over a quiet sea. We are not just alive. We are alive at the universe's moment of greatest possibility. This knowledge can be unsettling. If everything ends, is it worth anything at all? If the cosmos itself is impermanent, does meaning dissolve along with it? Philosophers have wrestled with this question for centuries, even before we knew the scale of the universe. Some have argued that impermanence robs things of value. Others suggest the opposite, that meaning can only arise because of impermanence. After all, if something is eternal and unchanging, it risks becoming invisible to us, a backdrop so constant we cease to notice it. Change and the inevitability of loss make us pay attention. From this perspective, a finite cosmos does not rob us of meaning. It sharpens it. Meaning becomes the act of cherishing, of recognizing the extraordinary in the moment before it passes. We cannot save the stars from burning out, but we can stand in the small window where they burn and marvel at their fire. There is another implication of living in a finite cosmos: connection. Everything that exists now, every atom in your body, every planet, every star, arose from a common origin. We are the products of the same explosion of being, the same ancient fire. When the end comes, everything will return to the same silence. In between, we are companions on the same journey. It is here that human meaning meets cosmic meaning. When we see ourselves not as isolated fragments, but as expressions of the universe itself, the briefness of our existence takes on a different flavor. We are not separate from the story, we are the story. And even when the chapter ends, the fact that it was ever written at all is astonishing. Sometimes, I imagine the universe as a vast, slow breath. The Big Bang was the inhalation, a rushing in of energy, matter, and possibility. The long night will be the exhalation, the release back into stillness. We are alive during the pause between those two movements, in the space where creation lingers before fading. In that pause, life blooms. Stars form and die. Minds awaken, question, and dream. We are the brief flicker in which the universe knows itself. And perhaps that is meaning enough, not to exist forever, but to exist now, in the one moment where existence can see, think, and feel. If the cosmos is finite, then so is our chance to notice it. Our task, perhaps, is not to resist that truth, but to embrace it. To gaze at the night sky not in despair that it will one day go dark, but in gratitude that it is bright while we are here to see it. The philosopher Jean-Paul Sartre once said, "Every existing thing is born without reason, prolongs itself out of weakness, and dies by chance." And yet, when we apply that to the universe itself, something in us rebels. For even if our cosmos began without reason and will end without purpose, the fact that it has shaped stars, oceans, forests, and the minds to contemplate them, feels like more than an accident. It feels like a miracle. Not a miracle in the supernatural sense, but in the sense of sheer improbability. The miracle is not that the universe lasts forever. The miracle is that it happened at all. In the next section, we will turn our gaze from the finite to the cyclical, exploring the possibility that the cosmos may not truly end, but rather transform. For while our current science points toward an eventual stillness, there are whispers in the mathematics and quantum possibilities that suggest a more daring idea, that the universe may rise again, that after the long night, there might be another dawn. There is comfort in cycles, in the idea that what fades will return, that what dies will be reborn. We see this pattern everywhere on Earth, in the turning of seasons, the migration of birds, the falling and budding of leaves. Even the atoms in your body are on their own endless cycle, forged in stars, scattered into space, and gathered again into new forms. It is no wonder that some scientists and many poets have wondered if the universe itself might follow the same rhythm. In the language of myth, this is the phoenix, a bird born in fire, living for an age, and then burning to ash, only to rise again, renewed. In the language of cosmology, this becomes the cyclic or oscillating universe, a cosmos that expands, collapses, and is reborn in an eternal sequence of big bangs and big crunches. Long before modern astronomy, ancient cultures imagined the universe as eternal in time, not in unbroken stillness, but in unending renewal. Hindu cosmology speaks of kalpas, vast cosmic days and nights, each one lasting billions of human years, during which the universe manifests and dissolves over and over. In some indigenous North American traditions, the world is created, destroyed, and recreated in a sacred rhythm, each age learning from the ones before it. These stories are not scientific in the modern sense, but they reflect a deep human intuition that beginnings and endings are not absolute, but part of a circle. For much of the 20th century, some physicists believed our own universe might be part of such a circle. If the force of gravity were strong enough, it could slow cosmic expansion and eventually reverse it. Galaxies would begin to drift back together, the universe contracting until it collapsed into a fiery singularity, the Big Crunch. From that singularity, perhaps a new Big Bang could erupt. The end would be the beginning. But cycles are not limited to the Big Crunch model. In more recent decades, theorists have explored the idea of cosmic bounces. In these models, the universe never truly hits a singularity. Instead, quantum effects, strange and subtle, cause the collapse to rebound, birthing a new expansion. Each bounce could be a new chapter with its own galaxies, its own stars, perhaps even its own laws of physics. In the 21st century, cosmologists have gone further, weaving in ideas from string theory. Some versions imagine our universe as a three-dimensional brain floating in a higher-dimensional space. Every so often, it collides with another brain, and that collision is what we experience as a Big Bang. From our perspective, it is the beginning of everything. From a larger perspective, it is just one of countless sparks in an endless cosmic dance. There is something intoxicating about this vision. If true, it would mean that the universe has no ultimate ending, only transformations. Death would be a doorway, not a wall. It also invites a question, both scientific and poetic. If the universe is reborn endlessly, does anything carry over from one cycle to the next? In physics, the answer is uncertain. In myth, the answer is often yes. Wisdom, memory, and spirit are carried forward, just as seeds carry the genetic memory of a forest through winter into spring. Some speculative theories suggest that subtle imprints from past cycles could echo into the present. There are scientists searching for faint patterns in the cosmic microwave background, relic radiation from the Big Bang, that might hint at a universe before our own. So far, the evidence is elusive. But the search continues, because if even the smallest trace could be found, it would change our understanding of time forever. Whether these cycles are real or imagined, they hold a certain solace. If the cosmos is a phoenix, then our story is not confined to one fleeting act. We are part of a greater tapestry, one that stretches across infinite rises and falls. Even if our particular galaxy will one day dissolve into darkness, the pattern itself will persist. The stage will be swept, the lights will dim, and then, one day, the curtain will rise again on a new play. And yet, there is a tension here. Cycles do not guarantee that we return. You reading this now, the earth beneath your feet, the familiar constellations, these may never exist again in exactly the same way. The phoenix of the universe may rise, but it will not be the same bird. In a way, this is both a comfort and a challenge. The comfort is that creation continues, that the story never truly ends. The challenge is to cherish our unique moment in that endless cycle, knowing it will not be repeated. We are not guaranteed an encore. This makes our time in the cosmos doubly precious. If the universe is a single performance, we should attend to it with all the reverence of someone hearing a symphony that will never be played again. If the universe is a cycle, we should still listen, for even if other symphonies follow, none will sound quite like this one. And perhaps this is the deeper truth hidden in the idea of cosmic rebirth, that renewal is not about duplication, but transformation. That the next universe, should there be one, will be its own mystery, its own experiment and possibility. It will not bring back what was lost, but it will bring something new into being. And in that sense, the phoenix does not merely return. It evolves. In the next section, we will explore how this idea of cycles and renewal might not just apply to the whole cosmos, but to its smallest parts, to the life cycles of stars, planets, and even the very particles that make up reality. For in a universe where everything changes, rebirth may be as close as the next flicker of starlight. The night sky is a graveyard and a nursery all at once. Every star you see is caught somewhere in its own private story, some just beginning to shine, some burning in their prime, some drifting toward their quiet end. And between them, in the dark lanes of the Milky Way, vast clouds of gas and dust lie waiting, ready to give birth to new suns when the time comes. If the universe is a phoenix, then stars are its feathers, each one born in fire, each one destined to return to ash, and yet from that ash, others will rise. A star begins as a whisper, a dense knot within a cold, sprawling nebula, a place where particles have been gathering for millions of years, drawn together by gravity's patient hand. Here, far from the warmth of any sun, space is cold enough to freeze breath, if breath could exist at all. And yet, this darkness hides potential. As gravity pulls matter inward, pressure builds. Atoms are pressed closer and closer until hydrogen nuclei, protons, begin to fuse. It is a process both violent and miraculous, releasing energy not as fire, but as pure light and heat. This is the birth cry of a star. From this moment, it will shine for millions, billions, or even trillions of years, depending on its size. The largest stars live fast and die young, burning through their fuel in just a few million years. The smallest, dim red dwarfs may live so long that not a single one in the entire universe has yet reached the end of its life. But no matter how long it lasts, a star's fuel is finite. When the hydrogen in its core runs out, the delicate balance between gravity and radiation falters. Gravity pulls inward, the outer layers respond by swelling outward. For a star like our Sun, this means transformation into a red giant, a bloated, luminous elder, its surface cooler, but its reach stretching far beyond its younger boundaries. For larger stars, the changes are more dramatic and more dangerous. Their cores become furnaces of heavier elements. Helium fuses into carbon, carbon into oxygen, oxygen into neon and magnesium, and so on until iron appears. Iron is the cosmic dead end. Fusion beyond it consumes energy rather than producing it. When iron piles up in the core, the star's death becomes inevitable. In a heartbeat, the balance shatters. Gravity wins completely. The core collapses in on itself, temperatures soaring to unimaginable extremes. And then, an explosion. A supernova. It is a death so bright that it can outshine an entire galaxy for weeks. It hurls the star's outer layers into space at speeds that defy comprehension. And in that scattering, the universe receives one of its greatest gifts, new elements. Everything heavier than iron, gold, silver, uranium, iodine, is forged in these dying moments of massive stars. Your bones contain calcium born in ancient suns. The iron in your blood was once in the heart of a star that exploded long before the sun was born. You are not just made of stardust. You are made of the dust of dead stars, the ashes of suns that burned their lives to give the universe new possibilities. Not all stellar deaths are explosions. Our own sun will not go supernova. Instead, when its red giant phase ends, it will shed its outer layers gently, forming a glowing shell of gas, a planetary nebula surrounding a small, dense remnant called a white dwarf. A white dwarf is no longer a living star. It is the exposed core, cooling slowly over billions of years, fading eventually into darkness. It will never ignite again, but the gas it releases into space will mingle with other clouds, becoming part of the raw material for new stars and planets. And so the cycle turns. The Orion Nebula, visible to the naked eye on a clear night, is one such stellar nursery, a place where the debris of past stars swirls into the bodies of new suns. From death, life emerges. From the collapse of one generation, the light of another is born. There is a quiet symmetry to all of this. Stars die, and in dying, they create the conditions for life, at least life as we know it. The oxygen you breathe, the carbon in your cells, the silicon in the rocks beneath your feet. None of it could exist without the deaths of earlier stars. In this way, the universe seems to have built itself on a principle of renewal, even if it does not intend it. Energy transforms. Matter recycles. Light fades, but is born again elsewhere. It is tempting to see this as intentional, as though the cosmos itself has a will to keep beauty alive. Perhaps it does not. Perhaps it is simply the result of natural laws playing out over unthinkable timescales. But even so, there is a kind of grace in knowing that endings are never absolute. The death of a star is not a void. It is a doorway. In the next section, we will step down yet another level, from the lives of stars to the lives of planets, and the ways they too can be born, destroyed, and renewed. For in the grand cycle of creation, even worlds are temporary, and yet, through their impermanence, they may carry the seeds for something else entirely. Planets are children of chaos. They do not appear gently, fully formed. They are born in violence, in the swirling wreckage left behind after a star ignites. Around that young star, leftover dust and rock, ice and metal begin to gather. Every particle is tugged by the star's gravity, yet also by the tiny pulls of its neighbors. These fragments collide, stick together, break apart, and collide again. Over millions of years, small clumps become larger ones, and larger ones grow massive enough to attract more material simply by the force of their pull. In these early days, the space around a newborn star is not peaceful. It is a battlefield of impacts and mergers, a constant storm of motion and destruction. Some worlds grow large enough to become gas giants, their thick atmospheres swallowing everything that drifts too close. Others remain small and rocky, like islands in a vast, dark sea. Earth itself began this way, not as a single rock, but as countless smaller ones colliding over and over until they became something large enough to hold on to an atmosphere, large enough to cradle oceans. And even then, it was far from finished. The young Earth was struck by a world the size of Mars, an impact so great that it tore away part of Earth's own body. From the debris, the Moon was born. It is easy to think of planets as permanent, as unchanging foundations. Yet they are as mortal as stars, slower in their lifespans, but destined to transform or vanish in time. A planet's life depends on many things: the stability of its orbit, the temperament of its star, the composition of its interior. Too close to its star, it may be stripped bare by heat, its oceans boiled away. Too far, and it may freeze into a silent, airless ice world. Even a perfect position is no guarantee. The shifting of tectonic plates, the eruption of volcanoes, the slow drift of continents, all of these can remake a planet's face over millions of years. Life, if it appears, may become one of the most powerful forces of change. On Earth, tiny photosynthetic organisms transform the atmosphere, filling it with oxygen and paving the way for complex life. But life also depends on the health of the planet's star, and stars, as we have seen, do not live forever. When a star like our Sun swells into a red giant, the worlds closest to it will be consumed. Mercury and Venus will vanish first. Earth, if it is not swallowed, will be scorched until nothing remains but barren rock. Planets further out may survive in some form, but their warmth will fade when the star's life ends. They will drift through space in cold twilight, their surfaces frozen, their skies forever dark. Some planets meet their ends in more dramatic ways. A collision between two worlds can destroy both in an instant, scattering debris into a glowing ring that may one day form new moons or planets. A wandering star, passing too close, can tear planets from their orbits, flinging them into the interstellar void. There are even planets that are swallowed whole by black holes, falling silently into the event horizon, their matter lost to everything but memory. And yet, just as with stars, a planet's death can be a beginning. When a planet is shattered, its fragments can seed new worlds elsewhere. Asteroids, rich in carbon and water, can deliver the ingredients for life to younger planets, just as they may have done on Earth billions of years ago. Even the destruction of Earth by the Sun, far in the future, will scatter its atoms into space. Atoms that may someday find themselves part of a new world, orbiting a new star in some distant arm of the galaxy. Worlds, like stories, are passed along. They leave behind traces, echoes, possibilities. Some of those possibilities may never be realized. Others may grow into something unrecognizable, a planet unlike anything we have ever seen, carrying within it the hidden history of everything that came before. It is strange to think that we live on a planet in the middle of its own life story. The continents we know now will not remain where they are. The oceans will rise and fall. Species will vanish, and others will emerge. Someday, perhaps millions or billions of years from now, this world will end in one form or another. But what it has made possible, what it has carried, will not end with it. From the perspective of the universe, a planet is not a fixed place, but a temporary arrangement of matter. What matters most may not be the rock itself, but what it gives rise to, the brief and improbable phenomena we call life, thought, and memory. And so, the death of worlds, like the death of stars, becomes part of the great renewal. In the next section, we will leave the realm of the physical and move into something more intangible, the memory of the cosmos, the idea that everything which happens, from the birth of a star to the thought you are having right now, may be recorded in the very fabric of space and time itself. There is a thought, quiet, ancient, and difficult to prove, that nothing in the universe is ever truly forgotten. Every light that has shone, every shadow that has passed, every motion, every vibration, every flicker of thought in the mind of a living being leaves an imprint. Perhaps not in a book, not in an archive, but in the very structure of reality. In physics, this idea sometimes appears as a suspicion that the universe is a perfect accountant, that it keeps a flawless record of every particle's position, every quantum state, every interaction, no matter how small. That even the whisper of a single photon brushing against your skin has consequences that ripple outward forever. If this is true, then the cosmos is not just a stage where events play out. It is also the memory of those events. We are used to the idea of memory as something fragile, something that fades when neurons die or paper burns. But cosmic memory would be different. It would be woven into the fabric of space-time itself. Think of a pond. When you drop a stone into it, ripples spread outward. They grow fainter as they move away, but they never truly vanish. They simply become part of the motion of the water. In the same way, an event, a star's explosion, the passing of a comet, a human heartbeat, may send its ripples through the universe, folded into the larger currents of space and time. There are hints of this in the laws of physics. The conservation of energy tells us that energy cannot be created or destroyed, only transformed. Similarly, the conservation of information suggests that the details of what has happened cannot be erased from the universe's bookkeeping. Even black holes, once thought to obliterate all traces of the matter they swallow, are now believed to leak their secrets slowly through what scientists call Hawking radiation. If this is correct, then not even the most extreme destruction truly erases the memory of what was. But cosmic memory is not simply about particles and equations. It invites stranger, more poetic questions. If everything is recorded, then somewhere in the geometry of the universe there exists a complete story of every sunrise, every moment of laughter, every note of every song ever sung. The light from a candle lit 1,000 years ago still travels outward, though it may be too faint for us to see. The radio waves from the first human broadcasts are still moving through space, carrying voices and music into the cold between the stars. What would it mean if the universe could play back these recordings? Could the light and vibrations of ancient worlds be reconstructed, like decoding an old photograph from a faint reflection? And if so, does the universe itself remember in a way we might one day understand? There is another layer to this thought, one that belongs more to philosophy than to physics. If the universe holds the record of all things, then perhaps memory is not something that emerges within life, but something life taps into. Perhaps our own memories are not locked inside our skulls, but are simply the ways in which our minds access the greater memory of the cosmos. In this view, when you recall the scent of rain on dry earth, you are not just replaying neurons firing in your brain. You are momentarily touching the exact configuration of the universe that existed when that scent first entered your senses. This is, of course, speculation. But it is speculation that feels strangely natural, as if our longing to remember is itself a clue to the nature of reality. Memory is not just about the past, it is also about connection. In a human life, memories weave together into the shape of a self. In the cosmos, perhaps memories, these eternal imprints, are what weave together the shape of history. When a star dies in a supernova, its elements are scattered across light years, later becoming part of planets, oceans, and bodies. But perhaps the memory of that star's light, the exact patterns it once cast on its orbiting worlds, still exists somewhere, waiting, unlost. Some ancient cultures imagined that the stars themselves were keepers of memory. The Egyptians saw the night sky as a place where the spirits of the dead traveled to live among the constellations. The Polynesians navigated the vast Pacific by reading the sky as if it were a living map, a record not only of positions but of stories and lineages. Modern science, though it speaks in different terms, still finds ways of telling us that nothing is entirely gone, that in the quiet structure of things, the marks of what has been remain. There is comfort in this, if it is true. It would mean that no moment is ever truly lost, not the smallest kindness, not the briefest spark of joy, not the faintest trace of a life that seemed to vanish. It would also mean that we ourselves are written into the great archive of existence, as indelibly as the galaxies and the stars, and that somewhere, impossibly far away, in the deep mathematics of the universe, the moment you are living right now has already become part of eternity. But if the cosmos remembers all, then it must also remember its own beginnings, the instant of the Big Bang, the first flickers of light, the birth cries of time and space themselves. Perhaps this is why, when we look deep enough into the universe, we are able to see its past. A telescope is a kind of time machine, gathering light that has been traveling for millions or billions of years. In astronomy, to look far is to look back. We do not just see stars as they are, we see them as they were. We are literally reading the memory of the cosmos, written in light. There is a thought experiment in physics called the holographic principle. It suggests that all the information about everything inside the universe could be stored on its boundaries, like a three-dimensional world being encoded on a two-dimensional surface. If this is true, then the edge of the cosmos is like a cosmic library wall, holding the complete record of everything that has ever been. And if there is such a library, then perhaps, in some unfathomable way, we are its pages. In the next section, we will take this idea further, into the realm where memory becomes destiny. We will explore how the stories written into the universe's fabric might guide its future, just as the past shapes the path of a river. This will be section 13, the echoes that shape tomorrow, where we ask whether the cosmos, in remembering, also dreams. If the universe remembers everything, then its memories may not be silent. They may be active, shaping, guiding, whispering into the unfolding of the future. We often think of time as a river flowing in only one direction, past to present, present to future. But what if the river is not free to wander anywhere it wishes? What if its course is carved by the sediment of everything that has ever happened? The river moves forward, but the shape of the land beneath it was laid down long before. In physics, this is not a mystical idea. The initial conditions of the universe, the exact way matter and energy were arranged at the very first instant, still influence the formation of galaxies billions of years later. Slight variations in the density of matter in the early cosmos determined where stars would gather, where voids would remain empty, and where life might eventually arise. The past, in this way, does not disappear. It is a scaffolding upon which the future is built. But what if this scaffolding is more than a passive framework? What if the memory of the universe, in some profound and subtle way, exerts a pull, a preference for certain patterns, certain repetitions? In nature, we see echoes everywhere. The spiral of a galaxy mirrors the spiral of a seashell. The branching of a river delta mirrors the branching of blood vessels. Fractals, rhythms, cycles. The universe seems to replay motifs as if drawing from a memory of forms it has loved before. These patterns might not be accidents. They might be the fingerprints of the past, impressed upon the clay of the present. Ancient cultures spoke of this in different ways. The Greeks told of the Enanche, the force of necessity that binds the unfolding of events. In Hindu thought, the concept of karma reflects a similar truth, that actions leave imprints, which influence what comes next. In modern systems theory, feedback loops perform the same role. The output of one moment becomes the input of the next. Different languages, different metaphors, but the same deep intuition. The past has a voice and the future listens. The very fact that life exists on Earth is a story of echoes shaping tomorrow. 4 billion years ago, the first replicating molecules found stability in certain chemical environments. Those conditions, warm shallows, volcanic vents, pockets of nutrients, created patterns of survival. From those patterns came cells. From cells came organisms. From organisms came us. The first flicker of self-awareness in some early ancestor did not vanish into the dark. It set a precedent, a memory in the evolutionary fabric, that consciousness was possible. Once the universe knew it could awaken in this way, perhaps it sought to do so again. There is a thought, half science, half poetry, that the universe is a kind of learning system, that it repeats not out of habit, but out of curiosity, that the great architectures of reality, galaxies, ecosystems, minds, are like ideas it has tried before and found beautiful enough to revisit. If so, then the echoes of what has been are not just residues. They are invitations, guiding the next act of the cosmic play. Even in our own lives, the pattern is familiar. We are shaped not only by the memories we hold consciously, but by those stored deeper, in muscle, in reflex, in instinct. These hidden memories tilt our choices in ways we barely notice. The universe, on its vast scale, might work the same way. Its deep time memories, imprinted in the geometry of space, the distribution of matter, the subtle laws of physics, may bias the path ahead. Some physicists entertain the idea of a block universe, a cosmos where past, present, and future are all equally real, all coexisting in a vast, timeless structure. In such a view, What we call the future is already etched into the same tapestry as the past. The echoes do not shape tomorrow because tomorrow is already here, waiting for us to walk into it. Others imagine a more dynamic reality, where probabilities shift and outcomes branch like the limbs of an ancient tree. In this view, memory is not a rigid script, but a set of pathways more worn than others. Trails the universe is more likely to follow because it has walked them before. There is a certain comfort in believing that the universe remembers what works, what survives, what blooms. That amid all the chaos and uncertainty, there is a quiet bias toward the harmonious. It does not guarantee a gentle future. Nature can be fierce, but it suggests that beauty is not an accident. Perhaps the same spiral that shapes a galaxy's arms will shape a hurricane's eye, and a sunflower's seed pattern, and the unseen architecture of a thought in your mind. The form is remembered. The echo persists. When you stand by the ocean and watch the waves, you are watching a present moment shaped entirely by the memory of wind patterns far out at sea, by the pull of the moon, by the contours of the shore carved by tides long past. You are watching the future being shaped by the past in real time. And when you make a choice to speak kindness, to create, to protect, that choice becomes part of the universe's memory. Its echo will ripple outward, shaping the path of someone else's tomorrow, perhaps long after you are gone. This is why every moment matters. Because every moment is a seed. And seeds, even if forgotten, know how to grow when the time is right. The echoes of the past do not only belong to the great scales of stars and galaxies. They belong to us. We are both the product of memory and the makers of it. The future will inherit our choices, the way rivers inherit the shape of the land. In the next section, we will follow this thread further, into the possibility that the echoes of the past and the futures they call forth are not mechanical repetitions, but something more mysterious. We will ask, if the universe remembers and shapes, does it also dream? Let me know if you need any further adjustments. If the universe can remember, then perhaps it can also dream. A memory is a tether. It keeps something from drifting into the void of forgetting. A dream is different. A dream is what happens when memory loosens its grip and lets imagination wander. And here we arrive at one of the most tender questions in all of philosophy and science. Does the universe merely replay its past in endless variations, or does it invent the new? On Earth, life began by repetition. Molecules copied themselves. Patterns reinforced patterns. The first cells repeated successful strategies. Evolution, for all its wonder, was built upon an ancient memory of survival. But then something changed. At some point, repetition gave way to novelty. Creatures began to evolve features that were not strictly necessary. Colors, songs, dances. Peacocks grew tails they did not need to run from predators. Whales began to sing. Flowers bloomed in shapes and colors that seemed designed not for mere survival, but for beauty. Where did this creativity come from? It was not in the original blueprint. It was extra. This extra, this surplus of expression, is what feels like the dream of the universe. It is as if, having remembered how to survive, the cosmos began to ask, what else is possible? We can see this even in the lifeless things. Crystals form not only efficient but beautiful structures. Volcanic eruptions leave behind rocks shaped like sculpture. Auroras dance across polar skies, serving no purpose but to astonish. It is as if matter itself enjoys moments of flourish, bending beyond necessity. Dreaming. In humans, dreaming is often a blending of old memories into new forms. Faces we know are placed into cities we've never visited. Events from the day are stitched into impossible narratives. We take what is real and we bend it until it is something else. Perhaps the universe dreams in the same way. It takes the spirals of galaxies and weaves them into the spirals of seashells. It takes the branching of lightning and threads it into the branching of rivers and neurons. The shapes are familiar, the memory is there, but their arrangement is playful. If this is true, then we might say that novelty is not the opposite of memory. It is memory in a state of wonder. A dream is just a memory allowed to wander into uncharted territory. This would explain why so much in nature feels both ancient and new at the same time. The first flower might have been born from the memory of a leaf. The first bird, from the memory of a reptile's scale. The first mind, from the memory of sensation. The past provides the seeds, the dream provides the blossoms. The question, then, becomes, is this dreaming conscious? We know that the human brain is capable of dreaming without awareness. Most dreams are not lucid. They happen in the dark, unobserved by the dreamer until they wake. Could the universe be dreaming in this way, without knowing it? Or, more provocatively, could it be lucid? This is the realm where physics meets philosophy. Some interpretations of quantum mechanics suggest that the act of observation shapes reality, that until something is measured, it exists only as a cloud of possibilities. In such a picture, the universe is not fully decided until someone, or something, looks. If the cosmos has observers within it, beings like us, then perhaps our awareness is part of its own. We are the neurons firing inside its vast, dreaming brain. When we imagine something new, a technology, a work of art, a different way of living, perhaps we are participating in the universe's dream. This is not a claim we can test in a laboratory, but it is an idea that hums quietly in the spaces where science and poetry meet. Consider how our own dreams often influence our waking life. A dream can give us an idea we act upon. A nightmare can make us avoid something. The boundary between the dream and the real is porous. If the universe is dreaming, then its dreams might spill into the physical, shaping the path of evolution, the birth of stars, the rise of civilizations. And here we come to a thought, both humbling and exhilarating. We might not only live in the universe's memory, we might live in its imagination. This imagination might be why novelty exists at all. Why, after the first stars were born, the universe didn't stop at stars. Why, after planets formed, it didn't stop at planets. Why, after life began, it didn't stop at life as simple cells. It kept layering, elaborating, experimenting. It kept dreaming itself into forms more intricate, more strange, more beautiful. And now, in us, the dream can speak. We tell stories, paint pictures, compose music, not because we must, but because we can. In our creativity, perhaps the universe recognizes itself. If this is true, then the responsibility is staggering. We are not just products of the cosmic dream. We are participants in it. When we imagine futures of peace, or create beauty, or invent solutions to problems, we are not merely daydreaming for ourselves. We are giving the universe new possibilities to remember. We are planting seeds in its imagination. But dreaming has its dangers too. Dreams can spiral into nightmares. The same capacity for novelty that gives us art and science also gives us weapons and destruction. This means that the universe's dream is not guaranteed to be gentle. It depends on what is imagined and by whom. Which leads to perhaps the deepest implication of all. If we are part of the dream, then the shape of the future, the universe's next chapter, is in part our responsibility. And so, as we move forward, we must ask ourselves, What kind of dream are we contributing to? One of beauty and flourishing, or one of fear and collapse? The echoes of the past, the memories of the universe, will always guide us to some extent. But the dream, the part that is free, that can create what has never been, that is the part we shape with our choices. We stand at the seam where memory meets imagination. And from that seam, the future will be stitched. In the next section, we will explore the possibility that memory and dream are not just features of the universe, but the very threads from which time itself is woven. We will ask, if the cosmos remembers and dreams, then is time simply the unfolding of its story? That will be section 15, Time as the Story of Memory and Dream, where we look at the fabric of reality not as a clockwork, but as a living narrative. If memory is the universe's anchor and dream its wings, then time is the sky in which both must fly. We often imagine time as a straight road, an arrow, moving from past to present to future. But what if this is only how we small creatures experience it? What if time is less a line and more a tapestry woven from two threads? The thread of what has been remembered and the thread of what is yet to be imagined. In this view, time is not a river carrying us helplessly downstream. It is a story the universe tells itself, and retells and edits and expands. Memory supplies the continuity, the characters, the recurring themes. Dream supplies the plot twists, the new chapters, the strange and dazzling turns no one saw coming. The past, in this way, is not dead, it is a living archive. The future is not empty, it is a field waiting for seeds. From the smallest particle to the largest galaxy, the universe seems to follow patterns. Electrons obey their quantum rules. Planets move in their orbits. Stars live, age, and die in cycles written billions of years ago. But alongside this order, there is unpredictability. Supernovae that erupt without warning, mutations that rewrite the fate of species, encounters between celestial bodies that change the shape of entire systems. Order is memory. Chaos is dream. Time is the dance between the two. Perhaps this is why the passage of time feels so different depending on where we are and what we are doing. Moments of pure repetition, commuting the same route, performing the same task, seem to blur together. Moments of novelty, a first kiss, the sight of a strange landscape, stand apart in sharp detail. Memory thickens the past. Dream sharpens the future. Time, to our minds, is a balance of both. In the deep past of the universe, before there were minds to measure it, time may have flowed differently, not in the tick-tock of seconds, but in the rise and fall of energy, in the bloom and collapse of matter. When the first atoms formed, the universe's story began in earnest. Hydrogen remembered how to be hydrogen. Helium remembered how to fuse. Gravity remembered how to gather things together. And yet, stars were dreamed into existence. Galaxies spiraled into improbable beauty. Planets appeared, some barren, some lush. The human mind is one of the few places where memory and dream are so obviously braided. We tell ourselves the story of who we are, and we constantly imagine what might come next. A life is not just a chain of events. It is a narrative shaped by what we choose to remember and what we dare to imagine. If this is true for us, then perhaps it is true for the universe as well. Some physicists speak of the block universe, a vision in which the past, present, and future all exist at once, and what we call time is simply our movement through this already complete structure. If that is the case, then memory is our way of looking behind us, and dream our way of looking ahead. But in another view, the one favored by those who see reality as still being written, the future is not fixed. It is a realm of possibility, shaped by each moment's choices, a story being told in real time. This second vision feels closer to how life actually unfolds. The next sentence is not yet written. The next chapter is still a mystery. We might say the arrow of time is not drawn by physics alone. It is drawn by the act of creation itself. When something new happens, truly new, the story of the universe lengthens. It gains a page, a paragraph, a single shimmering sentence that never existed before. Memory ensures that the page is bound into the book. Dream ensures that more pages will follow. In this way, time is not only the measure of change, it is the shape of the universe's autobiography. Think of how ancient trees keep their own kind of memory, rings laid down year after year, narrow in times of drought, wide in times of plenty. If you could read them like a language, you would find a story not just of seasons, but of resilience, of survival, of adaptation. The universe may keep its own rings, galactic structures, fossilized light, the background radiation left from its earliest moments. These are the records in its great book of time. And what of us? We are the only known beings who can consciously rewrite parts of this story. We invent tools that allow us to alter the course of rivers, to preserve endangered species, to build telescopes that look back billions of years. When we act, we change the trajectory of the dream. When we remember, we preserve the thread of the past. In this way, we are not simply passengers on the arrow of time. We are co-authors. But co-authorship comes with responsibility. A story can take many forms: tragedy, comedy, epic, cautionary tale. Which one unfolds depends not only on the physics of the cosmos, but on the choices of its dreamers. If time is the universe's story, then we must ask, are we helping it write a tale worth remembering? In the oldest myths, time was often personified as a serpent swallowing its own tail, as a weaver at an endless loom, as a river that flows both forward and backward. These metaphors capture something our science now begins to suspect, that time is not as simple as we once believed. Einstein taught us it bends. Quantum theory hints that it may branch. And in the deep realm of the human imagination, it loops, it folds, it even shatters, only to reassemble in new ways. Perhaps memory is the warp of the loom, and dream is the weft. Each is meaningless without the other. It is their crossing, their interlacing, that gives time its texture. We walk on this woven fabric every day, thinking it's solid beneath our feet. But step lightly, and you can almost feel the threads. And so, the story continues. The tale of a universe that remembers where it has been and dreams where it might go. Our role in it is still unfolding. We are both characters and narrators, both readers and writers. What we choose to recall will shape the roots. What we dare to imagine will shape the branches. Time, then, is not a prison, it is a living tree. And here we are, high in its canopy, looking both down to the roots and up toward the next unopened leaf. In the next section, we will follow this thought to its natural conclusion. If time is a story, then what happens when the story ends? Does the universe's memory fade into silence? Does the dream dissolve? Or is there another chapter we cannot yet see? Every story has pauses. The turning of a page. The breath between sentences. The moment when the music stops and silence holds the air. In the universe, these pauses are not empty. They are thresholds. Stars pause between heartbeats of fusion. Galaxies pause when their spiral arms slow before collisions birth a new shape. Life itself pauses between breaths, between the closing of one chapter and the opening of another. We fear these pauses because, to us, they look like endings. We call them death. But the cosmos does not fear its own silence. In its scale, death is never the final word. It is the ellipsis at the end of a paragraph, the sign that something is about to follow. A star's death, violent and blinding, becomes the birthplace of new elements. Iron, gold, calcium, the minerals in our bones, the metals in our blood, were all written into existence by a dying sun. What looks like the end of a life is often the universe shifting to another mode of storytelling. In human time, the pause can feel cruelly long. A forest takes centuries to return after a fire. A species gone extinct may never reappear in the same form. A loved one gone leaves an empty space in our own personal story, a gap we cannot fill with the same handwriting. But the cosmos works on a broader script, one that turns loss into transformation, one that sees death not as the closing of the book, but as the turning of the wheel. There is a moment after a star collapses when its core is neither alive nor gone, only suspended in a strange in-between state. Gravity presses inward, light struggles to escape. For an instant that may last millennia, the universe waits to see what the story will decide. Will it end as a white dwarf, cooling slowly? Will it explode into a supernova, scattering its memory into the cosmos? Or will it collapse entirely, becoming a black hole, a place where the story is written in ink so dark that no reader can turn the page? Even here, in the darkest endings, the universe holds a hidden continuation. Black holes may seem like final punctuation marks, but physicists whisper of Hawking radiation, of slow leaks of information back into the world, like a memory unwilling to be erased. On Earth, we know this pattern too well. After the mass extinctions of prehistory, life found ways to reimagine itself. When the dinosaurs chapter closed, mammals took the pen. When ice ages swept the stage clean, new forests and grasslands rewrote the scenery. The script never stops. It only changes authors, genres, and settings. Even our own bodies participate in this quiet cycle of renewal. Cells die and are replaced. The atoms that make you now once belonged to trees, to clouds, to ancient oceans. Your body is not a singular story. It is a library of many lives, each death contributing to the life you carry forward. We think of ourselves as individuals, but the truth is that we are living collages, a quilt sewn from countless endings and beginnings. In dreams, we encounter this same truth in symbolic form. We dream of falling, of losing, of being left behind, and then we wake into a day that is entirely new. A mind can weave its own small deaths and rebirths every time it sleeps. Perhaps the universe dreams in the same way. Perhaps each pause in its vast unfolding is a kind of cosmic sleep, where old chapters dissolve and new ones take shape in the dark. What makes this cycle profound is not only that it exists, but that it seems necessary. Without endings, nothing could change. Without pauses, the story would be a single unbroken breath, too relentless to carry meaning. Endings give shape to beginnings. They create the contrast by which life is noticed. Still, the human heart resists this logic. We love our stories in their current form. We do not want the characters to leave, the scenery to fade, the ink to dry. And yet, there is comfort in knowing that even the grandest of endings is still just a paragraph in the universe's greater book. Consider the phoenix, an image born in myth but resonant with cosmic truth. It burns, it falls to ash, and from those ashes it rises again. The fire is not the end, it is the method of transformation. Stars are phoenixes, so are forests. So is the universe itself, if the cosmologists who speak of cycles are correct. Some theories say the cosmos will expand until it grows cold and still, its story ending in quiet entropy. Others imagine it will contract again, collapsing into a point of infinite density, only to explode outward once more in a new Big Bang, a sequel written in entirely new light. The renewal is not always identical to what came before. No forest regrows in exactly the same pattern. No star reforms in the same shape. The past is never perfectly repeated, only reinterpreted. That is the gift of the pause. It allows the dream to take a different turn. It offers the universe a moment to edit itself, to shift the arc of its own myth. Perhaps the most poetic truth is this: without death, there would be no memory. Without loss, nothing would stand apart enough to be noticed. Memory, after all, is a record of what has passed, and dream is a record of what might yet rise again. So, when the story pauses, it is not the end of the dance between memory and dream. It is simply the music changing key. In the next section, we will explore the possibility that even if the universe itself one day reaches its final page, the essence of its story, its memory, and its dream may continue elsewhere. Imagine you are reading a book you love. You have followed it for hundreds of pages, walked through its landscapes, listened to its characters breathe and dream. And then you reach the last line. The final period rests there like a stone in a stream. The story is over, or so it seems. But you know what happens next. You carry it. It lingers in you. You recall its lines, its moments of laughter and grief. You think about the characters as though they still exist somewhere. A finished story is never truly gone. It becomes a memory, a living echo. The universe may work the same way. Even if one day it closes its covers, its essence may continue in some form we cannot yet name. Some physicists whisper about a cosmic archive, a place, or perhaps a law of nature, where every event, every atom's dance, is recorded in some deep structure of reality. The idea is almost mythic, that the universe's past is never erased, only stored in a language we have not yet learned to read. In human time, we see this reflected in the persistence of influence. A star dies billions of years ago, and yet its light still travels across space, finding our eyes tonight. Its chapter closed long before we existed, but its message still arrives, pages torn from the past, sliding across the cosmic wind. If a star's light can outlive its body, why not the story of the whole universe? Some theories speak of a multiverse, an infinite library where our universe is but one book among countless others. In that view, even if this particular cosmos ends, its memory may be preserved as a completed volume on a shelf without limit. And perhaps, another reader will open it. Perhaps another intelligence, in another reality, will read the story of our stars and our lives and imagine what it felt like to be here. In myth, this is the realm of afterlives. Cultures across time have imagined that when our own lives end, we continue elsewhere, not always in the same body, not always in the same form, but with something essential preserved. The ancient Egyptians imagined a soul divided into parts, some staying close to the earth, some traveling among the stars. The Norse envisioned Valhalla and Folkvanger, halls where warriors gathered after death. Hindu traditions speak of reincarnation, life returning in new shapes, new roles, new dreams. Each of these stories holds a common thread: the belief that endings are not absolute, that the page may turn to a chapter beyond our sight. If the universe dreams, and we have been asking throughout this journey whether it might, then perhaps its final moment is only a shift in its dreaming. The big freeze, the big crunch, the big rip. Each of these is a theory of how the cosmos might end. But what if, instead of ending, these are merely thresholds? Moments when the dream changes setting. In the big crunch, everything collapses inward. All matter, and energy folding into a single point. From the outside, this looks like finality. But from the inside, might it feel like falling asleep, only to awaken in a new explosion of light? In the big freeze, the stars burn out, heat spreads thin, and time stretches into an endless quiet. It sounds like death. Yet, in that frozen stillness, might something else begin? A slow forming of new order from the quiet fabric of space-time. In the Big Rip, expansion itself accelerates until galaxies, stars, planets, even atoms, are torn apart. It seems the most violent ending of all. But endings of violence have also, in nature, been seeds for astonishing rebirth. Our own existence is proof that continuation can come from destruction. Earth's early history was a chaos of impacts and fire. From that wreckage came oceans, air, life. If we had seen it then, we would have sworn the planet had no future. We would have been wrong. Perhaps the continuation beyond the last page is not something we could live to see in any physical sense. Perhaps it is carried instead by what the universe leaves behind, its elements, its patterns, its laws. Even if this cosmos ends, those patterns might seed the next, just as DNA carries the memory of life into new generations. Some thinkers have imagined even stranger possibilities. They suggest that advanced civilizations could encode their existence into the fundamental physics of reality, hiding their records in the fine structure of constants or in the cosmic background radiation itself. If that were true, then the continuation of our universe would not just be in matter and energy, but in information, messages waiting to be read by future minds. Information, after all, can survive in ways that bodies cannot. A poem survives its author. A song survives the breath that first sang it. Why not a universe? We may also think of the continuation as something subtler, something carried not in matter or memory, but in influence. When a star dies, it shapes the paths of nearby worlds. When a life ends, it changes the stories of those who remain. In this way, nothing ever fully stops. It ripples outward, and those ripples travel farther than we know. Perhaps the most humbling idea is that the continuation is already happening, right now, in ways we cannot detect. If other universes exist, ours may have already passed part of its story to them. We might be living in the continuation of a universe long gone, just as future beings may live in the continuation of ours. The last page, then, is not a wall. It is a bridge, one we cannot yet see the other side of. And so, when we think of our own ending, we might take comfort in the cosmic precedent that nothing is ever wholly lost, only translated. Translated into new languages, new dreams, new realities. Perhaps one day, somewhere beyond the final page, our universe will be remembered, not only for its galaxies and stars, but for the tiny world where creatures made of stardust wondered about the dreamer that dreamed them. In the final section, we will step into the ultimate speculation. If the universe's dream does continue beyond its own existence, could we, in some form, be part of that dream as well? If the universe is a dream, then perhaps we are its fleeting thoughts, sparks in the great, slow mind of creation. And if dreams can continue, if they can shift from one vision to the next, then maybe we too can be carried forward, woven into whatever comes after. We imagine endings as a vanishing, a candle snuffed, a curtain falling. But endings in nature are rarely pure erasure. They are transformations. A wave does not end when it meets the shore. It becomes part of the tide, part of the pull that shapes the ocean's next movement. The leaf does not end when it falls. It becomes soil, feeds roots, emerges again as new growth. So why should we imagine that the death of a universe would mean the disappearance of all we are? Perhaps what we call we is not limited to the atoms we inhabit, but is instead the pattern they form. If that pattern can be rewritten into the next reality, then part of us might awaken there, strangely familiar, without knowing why. We would not remember this life the way a dreamer does not remember every detail of the last dream. And yet, some echoes would remain, habits of thought, longings for the stars, a strange sense of déjà vu when we meet the shapes of constellations again. Science offers quiet parallels to this. Matter is never truly destroyed. It is changed, rearranged, given new form. Energy, too, shifts and flows, never ceasing. Information, if certain interpretations of physics hold true, is preserved, even when the physical form that carried it dissolves. It becomes hidden, scattered, but not gone. This means that on some fundamental level, pieces of the story we are telling now will still exist after the last page is turned. Myth has always held this hope close. In countless traditions, there is a place beyond the end, a river to cross, a field to walk into, a mountain to climb, to meet the ancestors. In some stories, the soul waits in this other place until a new world is born, and then it steps into that new dawn like an actor stepping onto a fresh stage. What if the universe itself does the same? The big crunch could be the deep inhale before a new breath. The big freeze could be the still winter before a cosmic spring. The big rip could be the scattering of seeds across a greater field we cannot see. And if those seeds contain us, then we are not left behind. We are transformed. To imagine becoming part of the next universe's dream is to imagine being made of the same laws, the same fundamental notes of reality, but played in a new song. We might not have the same names. We might not have the same planets, or even the same kind of matter. But the music could carry something of us forward, a rhythm, a melody line, a yearning for beauty and meaning that might one day make another set of beings look up and wonder who they are and where they came from. There's a humility in this vision. It does not promise personal immortality in the way we sometimes wish for it. We may not carry our memories. We may not meet the same faces again, but it offers something more subtle, that we will help shape whatever comes next, just as those who lived before the stars shaped our world, helped create the stage for us. We are the ancestors of futures we will never see, and there is a strange comfort in that. It means our lives are not only for us, but for the story the universe will tell after us. Just as the first cells on Earth could not have imagined oceans full of whales and coral reefs, we cannot imagine the forms that might come after our cosmos. Forms that may carry faint traces of our existence. The way our own DNA carries whispers from creatures long gone. Even in dreams, there are things that survive from one to the next. A recurring place, a familiar feeling, an image of water or light, or a face that slips through the boundaries between worlds. If the universe dreams beyond itself, we may be that recurring image. We may be the way it remembers what it once was and the way it wonders what it will become. So when the final star burns its last light, and when the great structures of space dissolve, it may not be an end at all. It may be the moment we begin again, unaware that we are beginning, but full of a strange readiness, like a seed in the dark before spring. And in that moment, whether we have form or thought or anything we now recognize, we will still be part of the dream. The dream will still be part of us. This is how the universe keeps going. Not by preserving every detail exactly, but by carrying the essence forward. The taste of starlight, the pull toward connection, the question of who we are. These things, perhaps more than planets and suns, are the real fabric of existence. And so, the next dream may begin with them woven into a new reality, ready to wonder again. We are not at the end, only at the turning of a page.